This video is hopefully to help you figure out how to run a script from R. And I'm going to walk through a script that is for the M3 lab that is for a one mode undirected data set. And so the data set that I've selected here is the Bali data set. And I'm going to actually just clear out my history since I've run this just to make sure it would look good for you. And first I need to make sure I'm running the igraph library. So if you haven't already installed that, make sure you install it. So all of this script here is coming off of the M3 lab, which is at the bottom of the page of the M3 documentation. And you would save that file and open it here. So in order, once I load up the script, it should look just like this, and I'm going to have you run through a few things to make it look like your data set. So in order to run each line, I'm just going to click on that line and hit run. And so I'm now using the igraph library. And if something contains a hash, so here I would like you to read that text in green, but this is just saying a few notes like, so you now need to import your data set. I did not make that part of the script. So in RStudio, I'm going to use a local file. I'm going to import this data set to the global environment, and I'm using the Bali dataset, and I want to show you one small change that I made to this. So I am going to open up and just show you that in this very first cell it had said ID, and I deleted that. And so you would change the CSV just by saving over and replacing that file. Since I've already done that, I'm not going to make any changes. But I am going to open that data set into my global environment. And there's another note that is here in the hash that I'm going to point out to you. So the way I want my data frame to look is that this first line, they have conveniently placed the heading to make it part of the heading for the file and not have those headers be part of the file. I'm going to say no, that is not a heading. So I want it to create this heading line and allow this to be part of my adjacency matrix to actually make these headings data. And so as long as your data set looks like this, you're good to go. If it does not look like this, be sure that you extracted your files from the zip file that they were uploaded as. That's one issue that came up for a couple folks. Okay, so I also want my attribute data set. I'm going to go ahead and import that from a local file. Moving on through, and one note about this, and so you're not going to be using an attribute data file today, but when you do use them, you do want those headings. That answer is yes. So no to Bali, yes to Bali ATTR. All right, so for the naming conventions, you're going to need to change this to whatever the name of your data set is. And if you were to delete it and then start typing something in here, it's possible it may give you a few suggestions when you start typing something in. So that will help you make sure you don't make any misspellings and get error messages for those reasons. But I'm going to recreate this to say links and nodes, and you could keep a different name here, but if you're using the script, you may want to use these two in order to not have to make many changes to the script. So I'm going to run this to create links within my global environment. I'm going to create nodes with my global environment. And then I need to tell that I would like that to be or to recognize it as a matrix rather than just a data frame. So I'm going to run that, and now I've created links as a matrix, but I also need to tell it that I want it to be a graph. And so it's an adjacency graph, and so this is the command that we would use for that, which is slightly different than what was in the assignment. I've entered a different command here, and you're going to want to know if your data set is undirected or weighted. So if you do have an undirected data set, then you would leave it as such. If you have a directed data set, you would delete this part here. And if you have a weighted data set, I mean, you can just say, don't pay attention to that, to the weights. So I'm going to create net as my graph, and it's going to give me a warning message, but everything's fine. It's letting me know that I have some things that might be notable if this was a different type of data set. And now I want to get to understanding what my network size is. So eNet and VNet are going to tell me the number of edges and the number of vertices, or the number of links and nodes that I have. So when I run this, it's going to tell me every single edge in my network. V2 is connected to V3, V2 is also connected to V4, V2 is connected to V5, and so on. But the answer to network size would be that there are 63 edges, and there are 18 vertices, and it lists them. Let's plot it. Looks beautiful. All right, I'm going to calculate the average distance by using this mean distance command of net. Again, note if you have a directed data set, you would respond T here for true. So my mean distance is 1.58 path lengths across my data set. So everyone can be reached typically within 1.5 nodes. I want to look at my diameter across the network. So I'm going to calculate that. Answer 3. I am going to calculate centralization. So that's going to be the third thing that shows up here. And my network is 47% centralized around one node. The edge density, I want to know of all possible ties, how many ties are present. 41% of them are present. And now in order to calculate the mean degree, I first need to calculate this degree and the degree of each node. And so this is the degree centrality of each node. So one node, V7, which I imagine is this one, has a degree centrality of 10. It probably has about 10 links, or it has exactly 10 links. Now I want to get the mean, so I need to calculate degree first and then get that mean degree. The mean degree, or the average degree of centrality, is 7 for this network. Now I left this line of code in. If you have an undirected network, you're going to have to symmetrize your data set. If you don't have a directed data set, it's not going to hurt to run this line. So I have an undirected data set, but I'm going to run this line to symmetrize it. Because it's already symmetrized, it makes no difference. But I'm now so now I've created NetSim, and the following sections are about NetSim. If you don't run this line, you have to change this to the name of your graph. So I want a list of all the cliques in my network. I click run, and it starts running like crazy. It found all of these formal cliques. So all of these are fully connected subgraphs within my network. There's a ton of them. If I scroll up, you see that it just lists them all out. I have to scroll up and up in order to see them all. So how about we see the size of each one of those cliques? If I run this, it's going to tell me each one of the clique sizes. So I have multiple lines. So this is the largest clique has 9 individuals. The smallest clique only has 1. So each node is in its own clique by this definition, because I didn't say the minimum size in order to be considered a clique is this. In order to give you an interesting graph, I added in, I just want to calculate what the largest clique is. And so it says these vertices are part of that 9-person clique. And I'm going to start creating a column up here that says, I'm saying that in this graph, I want a characteristic to be gray, because I want to color code some nodes as gray. And the ones that are part of my largest clique, I'm going to make those gold. And now I'm able to plot that largest clique in gold, as all other. So that's kind of fun. I accidentally have Same thing. Again, it turned it a little bit. All right. Well, that is everything. I hope you've enjoyed this demo and I hope it is really useful to you.